Hi everyone, let's walk through this question together. First of all, pause, read the question, and let's get into it. Now we're talking about the Voronoi diagram, meaning that every single point that are separated by the edges or the dashed lines will be equidistant to their intersection points. So let's say there's T4 is right around there. That means A to T4 is equal in distance or equidistant to A to T2 and A to T1. At the same time, T4 to B is equidistant to T2 to B and T3 to B. Understood? Alright, so let's go to the first question. Explain why Tim will receive the strongest signal from T4 when Tim stands inside the shaded region. Well, that's just how Voronoi diagrams work. It doesn't matter whether Tim stays there, or there, right? Because every single point within the shaded region is closest to T4. It is only when Tim stands away from it. For example, if Tim stands in the area that is within where T1 is located, then Tim will be closest to T1 because that's just how Voronoi diagrams work. Now, the next question is, write down the coordinates of T4. This is a very important part of Voronoi diagrams. The neighboring points within a Voronoi diagram is perfectly reflected by the edge or the line that separates them. In this case, between T2 and T4, there's the edge or the line AB, meaning that T2 is a perfect reflection upon the line AB. And this is a huge advantage for us to know. We know that based on the question that AB follows the line or the gradient y equals 3, not gradient, but equation y equals to 3, while T2 is at a point of negative 9, 5. Because it is a horizontal line that separates them, it's actually very easy for us to find T4. All we have to do is calculate the vertical distance between T2 and AB, which is 5 minus 3 equals to 2, and we do the same one more time going down, meaning that the y value would be 1. What about the x-axis? Because AB is perfectly horizontal, that means the x-axis stays the same, meaning that T4 has a coordinate of negative 9, 1. Perfect. Tower T1 has coordinate negative 13, 3. So I'm just going to put this here, negative 13, 3. Find the gradient of the edge of the Voronoi diagram between towers T1 and T2. Now, we can use the same principle. Well, it does follow the same principle of the edge line A that separates between T1 and T2 is supposed to be the perfect mirror between the two of them. But we don't really have to do that here. There is another thing that we have to understand, or we should be able to spot, which is the fact that every single point, every single 2 points, every pair of points within a Voronoi diagrams can be represented as an isosceles triangle. So I'm going to, let's see, how will I best do this? So for example, A to T2, I'm going to make a triangle here, right? Between T1A and T2, that is an isosceles triangle. Similarly, if I take the point from T4, that is also an isosceles triangle. And between A, T2, and T4, that is also an isosceles triangle. And this is very important because if it's an isosceles triangle, that means there is a perpendicular line. We're trying to find the gradient of the edge that separates T1 and T2. And for us to do that, we must first find the gradient of T1, T2. So for the sake of simplicity, let's say T1, T2 has gradient A. What we're trying to find is gradient B, MA and MB. So let's go to the next page. Let's first write down our coordinates. T1 is -13.3. M1 equals to not M1, T1. T1 is -13.3, while T2 is -9.5. I'm pretty sure it's -9.5, right? Yes, -9.5. Let's just make that pretty. Okay, -9.5. For us to find MA, it would be y2 minus y1 over x2 minus x1, which means that it is 5 minus 3 over -9 minus -13. You will get 2 over 4, or half. Now, how do you get MB? Because MB is what we're trying to find, right? There's a rule when it comes to perpendicular gradients, which is MA equals to -1 over MB when MA is perpendicular to MB. So in this case, all we have to do is substitute it in. 1 over 2 equals to -1 over MB. Push things around and you'll get MB is equals to -2. And there you go. A 6-mark question in about 6 minutes.